starters, the official time for the final exam will be 10:10 a.m. on Wednesday. That sounds correct? I have a slide here at the end. All right, so I will put the exam will be up on Blackboard. I will have it up on or before 7 a.m. on Monday. I may get it up earlier than that, but I'll guarantee it by then. You can take the exam whenever you want, but I will definitely be available from 10:10 a.m. until noon on Wednesday. I'll sign into Zoom, so I'll be live in Zoom, and I'll be on Slack. So if you are taking it during that time and want to pop in and ask a question, or even want to just sit in the Zoom room while you're taking it, that's fine, whatever makes you happy. So there will be a live session for the exam if you would like to attend the exam at the normal time. Otherwise, you can take it whenever you want. You do have to do it in a single sitting. I'm going to design the exam to take an hour. I will probably set the time limit at 3 hours. I will try to, I know many of you took longer on the midterm than I had anticipated. And I'll try to bring some awareness again, kind of remind you some of the things that a lot of folks, I think, made it a lot more difficult than it needed to be. But I'll hopefully make it a little bit clearer what I'm asking for maybe on some of the questions, so that you don't go down some sort of path where you're spending a zillion hours on a single question when it was really something that should have taken 5 minutes. But my attempt will be that it'll be an hour-long exam, but I'll give you plenty of time to take it so that you can it doesn't have to be a time stress thing. It is closed book, closed note, closed neighbor. So it should be your own work. Don't work in groups and things like that. You can use a calculator. Yeah, so any other logistics questions about the exam before I kind of flip through the slides and tell you what things seemingly are more important versus or less important? You get what the deal is with the exam for next week? Go ahead. Yeah, my usual policy. So if you get a better score in the final exam than you did in the midterm, I'll replace your midterm exam score with whatever you earn on the final exam, not the other way around. You can't do well in the midterm and just ride it through the final. But if you do better on the final, which I anticipate that being the case. I think there were several people in here that struggled on the midterm when they typically wouldn't have struggled on my exams. I think maybe because they made questions harder than they needed to be. So hopefully you'll have the opportunity to remedy that on the final exam. All right, other questions about logistics of it? All right, and I'm planning on, I'll probably write it tomorrow is what's the plan. And I'll probably just put it up as soon as I have it written. So if you wanted to knock it out this weekend, you can, but I don't want to promise that it'll be up tomorrow. Who knows what will happen, right? It'll be up by 7 a.m. on Monday, but there's a pretty good chance it'll be up sometime tomorrow is my guess. And I'll put an announcement. So when I actually make it live, you'll get some sort of email announcement, and you can decide when you want to set aside the time to do it. All right, so let me flip through the slides and kind of highlight what is kind of the highlight reel. I will probably try to have a lot of the emphasis be things since the midterm, and we'll swing around on that here in a few minutes. But I'll throw out there the same thing that I warned beforehand. We practiced after the exam, one of our labs. But there will be questions where I say you can assume you have a linked list. or you have a stack, or you have a graph, you have one of these data structures and it already exists. And I want you to solve some problem using that data structure. Okay. When I'm giving you a question like that, I'm not asking you to rewrite the data structure. I'm not, your code shouldn't have like something dot next node equals this and that kind of stuff. You should be using the structure that is a linked list, you know, get front or get at index 4 and use that thing that came out of there. You know, I want you to use those power tools in those questions. So, you know, so like in the previous exam, dealing with stacks, understanding how stacks work and that they're a last in, first out linear link data structure. You know, in that particular case, if I think I had a question on there like reverse a stack, something like that, where you have to kind of create a secondary stack, pop everything off the first one, and kind of put everything back on after going through a linked list. I want you to use the tools, not rewrite the tools. Okay, so really try to keep that in mind as you're doing the exam, because I think that concept right there is what turned the first exam from an hour-long exam into a 2.5-hour-long exam for a lot of people, where that wasn't the intent. All right, so everybody's clear on what I mean by that. I think it's pretty unlikely that I'm going to ask you questions on the exam. They're going to have you heavily setting like previous node dot next node is equal to this dot next node or something like that. So if you find yourself writing lines of code like that, you're probably misunderstanding the question I'm asking. Okay. And like I said, if you think you might be prone for that and you want to have the comfort of clarification, I'll be in the Zoom class and also on Slack at the normal time of the exam, and feel free to take advantage of that. All right. Now, if nobody shows up to the Zoom meeting, I'll probably still keep it live, but it's possible to be in the background. So if you have a question, kind of yell, say something, so you wake me up that there's something going on. Don't just throw something in the chat because I might not see it. Okay, so let's flip through here. I think I probably covered this in the first before the first exam. I'm not going to ask you anything about structs. We should be aware of them. At some point in your career, you might have to deal with them, especially if you get into an industry where you are working with C or C++, because you're probably going to be maintaining some older code. But the modern programmer working with modern object-oriented languages, structs are just not really a thing anymore. They really probably should still be a thing, because we understood in here that they do behave differently, right? Structs are passed by value by default, where objects are passed by reference. So they really aren't equivalents, but I would say in industry, they've mostly been treated as equivalents. So obviously you should be very comfortable with pointers at this point. On the exam, I won't ever rely on you knowing what the size of something is. So like from a trivia perspective, you probably should know that a char in Java is 16 bits, a char in C++ is 8 bits. But if I'm asking you to do something with like creating enough memory for something, or ask you how much memory would it take to, how much contiguous memory would be required for a 100 integer array, I would say where an integer is 32 bits. I would give you the size of whatever I'm telling you to ask, or if I what like an array of objects. So I'm kind of thinking like this might be a question I would ask if I say there exists an object called a node. How much memory would it take to hold 50 nodes? And I would say where the size of a memory address is 32 bits or something like that. So I want you to understand how to just do that math, but I won't ask you to just have this background knowledge of how big a certain thing is. Another good question, especially if I'm asking you to kind of rate your own object for something. Make sure you read the questions pretty carefully. It's possible I might ask a question along the lines of create an object called person or player or whatever that keeps track of these 3 or 4 pieces of information. Show me the header file for that, where I'm kind of showing you, tell me what that guy would look like, but don't actually implement him. Just give me the header file portion. All right, so definitely show that you understand the difference between a header file, the .hpp file, and the CPP file. So again, that would be a kind of question that would be in danger of you spending 15 or 20 minutes on something that really should have taken 5 minutes. All right, because if I say just give me the header file, I'm just asking for, the public stuff, the private stuff. Show me that you understand that a constructor needs to be prototyped in there. Maybe there's a couple of getters if I ask for that, but I'm not asking you to actually implement them. And frankly, for your typical object, most of the implementations of those things are like one-liners, right? Return first name or something, but I'm not asking you to do that unless I specifically ask you to do that. So pay attention to the words I use in the question. So certainly the linear linked data structures will be fair game on it. So linked list, stacks, queues. I will probably err on the side of the non-linear ones, but the linear ones will be represented on there, at least in a couple of questions. As usual, there will also be at least one conversion question. So you should be able to convert from one base to another base. Similarly, you should be able to convert from sizes. So if I say, how long will it take to download a 3.7 gigabyte file over a 100 megabit per second internet connection, you should be able to do the math. Understand the difference between bits and bytes and that scalar of 8 and the scalar of 1024. So you would tell me how many seconds. But there'll probably just be one of those on there. And hopefully everybody already understands that stuff. So that's not going to be that will behave more like a free 10 points than anything else. There will probably be something on there with binary trees. Again, I might show you a tree and say, what would be the order you would visit the nodes in if you were doing a post order traversal or something like that. I would not have anything with implementation of a heap, but you should know what a heap is. That a heap is an implementation of a priority queue. Well, it's a description of a priority queue where the implementation can be done in various ways. We looked at the implementation as a binary tree being the implementation for it, but we didn't write it. So in any case, it would be fair game for me to say, you have access to a heap, and here's the 2 or 3 functions that it has. And you would understand that when you add something to the heap, it gets stored in a place where the most important thing, you have a min heap and a max heap, the most important thing in a max heap would be the thing that has the maximum value. So regardless of what order you put stuff into a heap, when you take something out of a heap, when you dequeue it, okay, when you take something off the front of the line, it will be the largest value you put in regardless of what order you put it in there. Make sense? So when I say you have a heap, make sure you understand what that tool does, what a heap does. Nothing with bitwise operations on the exam. That was more of like, hey, if you ever accidentally do this, this is why you'll get a weird answer. This was us looking at how do we kind of navigate a tree using the bitwise operations. I probably won't ask you anything with it. It's pretty mathy and not necessarily exam friendly. And that's why we didn't really implement the heap. Is it's academically interesting, and you can probably throw enough hours at it to figure it out, but maybe not the best use of time. Okay, so graphs, understand that the difference between an undirected and a directed graph in terms of whether or not the edges go both directions, or if it's a one-way edge. I probably wouldn't have you implement a graph on the exam, but I might ask you to use a graph that exists. And I would tell you, here's the abilities this graph has. And then have you solve some problem using it or something like that. Understand the terms vertices and edge. So the vertices are the actual nodes in a graph. The edges are the, in our most recent example, the vertices are the towns, the edges are the roads. You won't need to know the difference between these different kind of flavors of graphs that we talked about. This was more of an academic thing. It would be fair game, specifically for Dijkstra's algorithm. That's a pretty famous algorithm. I think there's value in knowing how it works. For me to maybe give you a graph that looks kind of like this, maybe I make it more generic, like A, B, C, and D, or maybe I give you the actual towns, and say, show me the value for each of our vertices after applying Dijkstra's algorithm, given our starting value of Grafton or something like that. And we had an assignment that covered that. We did a single pass on Dijkstra's algorithm where I think we chose Mequon or something as our starting thing. So no Dijkstra's algorithm to the point that you could tell me what each of those vertices has for those two values. Whatever the two values are, how long did it take to get here total? And who was the guy that got me here immediately previously? What road got me here? And even on a more generic level, know what Dijkstra's algorithm is solving, shortest path between places given a starting point. It doesn't necessarily solve the traveling salesman problem in its entirety. It's part of the solution to the traveling salesman problem. You should also be aware of the traveling salesman problem. I don't know if I'll ask a question specifically about that, but it would be fair game to understand that it's this famous problem and that it's computationally very difficult to consider what are all the possible orders. That's kind of back on this slide here where we talked about, if you're going to work and you need to stop at the coffee shop, the post office, and the bank on the way, there's all sorts of different ways you can visit those places, which is the best path. Punchline for us is traveling salesman problem is a complex thing. Punchline for a future class, if you end up doing the quantum computing class, I'm not sure if it'll be offered next fall or next spring, but we look at solving the traveling salesman problem using that, and it actually ends up being a very fast solution using quantum computing. It's kind of an interesting complement, as some of the problems that are hardest to solve with classical computers are actually not easy to solve, but performance wise don't have the same hangups in the quantum computing side. Yeah, so here's like basically know how to make these. Follow Dijkstra's algorithm on this guy. Trying trying to think if I would even ask something about compression. It's fair game to know why we might compress stuff, you know, so I might ask a question regarding understanding the need for compression. I wouldn't ask anything specific about Huffman codes. I suppose I might ask something about Huffman coding similar to, I wouldn't ask you to apply the algorithm. We didn't implement it, but you know, you should know that in general, Huffman coding attempts to represent the most common character occurrences in text with the smallest replacement character, with the idea that you will get a reduced final size of your text. So kind of understand the high level idea of what Huffman coding does. And then I would say there might be, we'll finish up the discussion on it today, you know, something dealing with blockchain, but again, the focus on it from an algorithmic perspective might be on that SHA-256. What's a hash algorithm? That type of thing. You should understand that hashes are one-way ciphers. You know, you pass an arbitrary size data through some sort of algorithm that spits out a fixed size output. And that's what a hash does, with the caveat that you can't reverse it. Once you, if you have the hash value, you can't go back. You can only rehash the data and see if it matches, to see if you very likely have the same data in the end. From a blockchain perspective, understand that it has a relationship with linked lists. That's the way we're looking at it. So I'm not going to ask you questions about Bitcoin, is what I'm getting at. So understand that blockchain is effectively a modern implementation relying on the ideas of linked lists. Each block is reverse linked to the hash of the previous block, adding security to it. I probably wouldn't go into more detail than that. So maybe understand what's the unique nature of blockchain relative to a standard linked list. Let's see, is this kind of where I stopped? Is the smart contracts? We didn't get here yet, right? Did we start talking about smart contracts yet? We probably were talking kind of right in this area when we finished. Okay, so I'll leave it at that for topics of the exam right now. We'll see where we get by the end of class today. If I want to tack anything else on there that might be an interesting question for the exam. Smart contracts could fall into that category, but let's just see how the information comes out. And then I'll let you know. But based on what I've already talked about, are there questions about the exam? Go ahead.
So like the graph and stuff, are you gonna like if it was a graph question, would you just be asking us to manipulate like a variable graph or whatever, something, or would you be asking us specifically about like this town project you kind of did?
Yeah, I'm trying. It would probably have to be something along those lines, because that's really the only application of graphs that we really looked at. I would think that for writing methods, it would be a much higher chance that I would say you have a linked list, a stack, a queue, a heap, or a tree, a binary tree. I think saying, assume you have a graph, write a function that takes a graph as a parameter and do something with it, I would say that's probably going to be more difficult. So realistically, a question about the graph might be like the applying the Dijkstra's algorithm type thing, just because we don't have a, they tend to be harder algorithms anyways, but also we don't have a lot of practice of applying graphs to other things. What else? Okay, so then let's keep cooking here. So as a reminder, last class we were talking about Last class, we were talking about this blockchain stuff, but really focusing on it from a data structure perspective, thinking about it as like a very special implementation of a linked list where the feature of this guy is that when we look at a blockchain, so this kind of looks like a linked list where each of these guys is a node on our linked list, but these guys have a relationship to each other in that so our node here really holds two different pieces of information, right? Well, more than two, but we can think of it as two broad pieces of information. A node holds a header and a node holds a collection of transactions. Doesn't really matter. That's more of the cryptocurrency side of this. These nodes hold two pieces of information, okay? But now the interesting relationship of this special application of linked lists is that the header, one of the pieces of information of a node, has as part of it the hashed value of the header of the previous node. So he kind of knows about the secret code of the previous guy, which then protects the integrity of that blockchain if somebody were to try to come in and manipulate the linked list and say, oh, this is actually block one. This guy would no longer correctly link the guys before it. You probably could mimic block one to the two block one here. So block one knows about block zero. You could use block zero's hash and put it into block one and say, hey, this is the right next guy. But where it breaks down is when you get to block two existed in terms of the hash of the original block one. It won't be correct for the new fake block one. Okay, because he knows about the special magic code of the guy that was supposed to come before him. All right. Kind of makes sense what blockchain really is. All right, because really, I mean, I think I tried to emphasize this last class. I'm a huge advocate for blockchain, and from a computer science perspective, I'm an advocate for applications of blockchain beyond, grandpa buying milk with Bitcoin. That's just not a thing. So I don't know, my encouragement would be if any of you are currently in cryptocurrency stuff, if it's fun and you're just wanting to be exposed to it, great. But make sure you exit at the right time is kind of the deal. I really do think, and we're going to talk about NFTs here in a few minutes, that we're just now moving past. I mean, the cryptocurrency piece is still there, but we're just now starting to entertain more legitimate uses of blockchain through these things called NFTs, which are based on these smart contracts, which we're about to talk about, and also some specific uses. Did I mention? Oh, go ahead.
I just read about some guy who can do years-long study.
Okay. So, but specifically looking at blockchain.
Yeah.
I got you.
So I don't know if we mentioned more with,
Yeah, I mean, what's interesting about it, so I've been doing blockchains stuff. When I first started doing it, Bitcoin was worth less than a penny. And I'd argue I exited at a pretty decent time. So it's kind of a unique perspective where I hugely financially gained from Bitcoin and other cryptocurrencies, yet I'm telling you that's not what they're for. It's just good luck. It's like, coming across a bunch of gold, saying you're going to sell it and moving on with life. Right time, right place, whatever. There are some pretty exciting technologies right now. Did I mention Ripple and Stellar Lumens last class? So when you deal with these blockchains, let's go right after this. I want to differentiate the blockchain versus the token. So all blockchains have a default token. This token must exist in order for validation to exist on the blockchain, as new tokens are born every X number of minutes as a result of the previous block being validated on the chain. So the idea would be is with Bitcoin, for example, every 10 minutes, a block is going to be added to the blockchain. And a bunch of people have to agree that this is the right next block. All right. And there's like this big race of these people doing math problems. These are called Bitcoin miners, crypto miners. There's a big race. They're doing these hard math problems using a ridiculous, unreasonable amount of electricity these days, yada, yada, yada. We're looking at alternate ways of doing the validation, but doesn't matter. That's not related to the blockchain portion of this. But in any case, there's going to be a winner. Okay, somebody is going to end up finding the right hash and validating this thing, and because it's kind of like trial and error, just doing all these different things. So in the end, there's going to be a winner. Let's just say it's a single guy. It's probably you're mining as part of a pool. But when you're the winner, every 10 minutes, I think right now it's 6.25 new Bitcoin are born. And that keeps halving every 4-ish years or something like that. So that means whoever validated the last 10 minutes block will get 6.25 Bitcoin. That's how new Bitcoin are born. These aren't Bitcoin that are currently on the blockchain. These are brand new Bitcoin that are now released onto the blockchain. All right, so this is how they're inflation resistant, because we know how many Bitcoin will ever exist based on this math problem. And we know how many will exist 10 minutes from now, and 10 minutes after that, and 10 minutes after that, so on and so forth. So there must be a default token in all blockchains in order to deliver that reward. Now, that doesn't mean the reward's worth any money, right? Every blockchain is going to have this default token, and this new tokens are born as a result, in most of the algorithms are born as a result of validating the last block onto the blockchain. But you know, it could be a chicken McNugget token. It doesn't mean it has value. It's just there's the thing, you're collecting tokens. All right, but the connection I want to make here is Bitcoin is the default token on the Bitcoin blockchain. Ethereum is the default token on the Ethereum blockchain. Lumens is the default token on the Stellar blockchain. I wanted to throw that out there as an example where the token and the blockchain don't always match in name. Ripple is the default token on the Ripple blockchain, but they usually do. It's kind of the punchline. All right. I am a fan of these last two because they solve a real life problem. Just as I've said that, you know, grandpa's not going to go and buy milk with Bitcoin anytime soon. Your debit card works just fine, or cash works just fine, whatever. We do have a real life problem with banking systems. So for instance, if, especially now that we have a world economy, right? We've had it for a while, but it's not uncommon for people to need to move money from an American bank to a Chinese bank, for example. And these two banking systems, the Chinese banks are compatible with banks in China. The US banks are compatible with banks in the United States, but these two banking systems don't know how to talk to each other, right? So if you want to move 100,000 US dollars from a US bank over to a Chinese bank, it's a headache. It takes a couple weeks. It's passing through lots of people's hands. There's areas for, lots of opportunities for corruption. There's high fees, all this stuff. The idea would be is you turn 100,000 US dollars into Ripple. That money then travels along the Ripple blockchain to a wallet in China, and then you convert it from Ripple back into the Chinese yuan. You've now moved it from a US bank to a Chinese bank using blockchain as the transport. You temporarily represented a fiat currency like US dollars and the Chinese yuan using Ripple as that. Lumen is, Stellar Lumen solves the same problem. One's for profit, Ripple's a for profit company. Stellar Lumens is open source. Pick your poison. But they're focusing on solving that same problem. Those are legitimate uses of things like blockchain, because of what we've talked about here with blockchain and how the chain itself is protected from the idea of having the previous node knowing about the current one from the hash value of it. That is a secure way of transporting that money, but that whole transaction is probably taking less than 3 seconds to go in with US dollars and come out with Chinese yuan. And the idea is that it's, yes, cryptocurrency is fairly volatile. So if you look at the price of Bitcoin at different points of the day, it's all over the place. You look at it across a 2-week period, it's all over the place. Most cryptos the same thing, but hopefully within a couple of second time period, there's not going to be a ridiculous amount of fluctuation. You've maintained relatively the same amount of value. That 100,000 US dollars didn't turn into 50 bucks, 1 second later. I guess anything's possible, but that feels unlikely, right? So those are legitimate uses of blockchain in my view. Bitcoin, I don't even understand why people are still into Bitcoin. It's just because it's the original cool kid, and I think the thing is that right now on a daily basis, the amount of electricity that the Bitcoin network takes is more than the country of France. That's ridiculous. It's just ridiculous. That's a lot of energy for no good reason. Go ahead. Yeah. Tesla accepted Bitcoin. You can buy cars with Tesla for 15 minutes until people called them out on, Tesla is supposed to be about being green, right? Using electric vehicles, yet they're taking currency that's using more than the power of France for a given day. So they stopped doing that 20 minutes later. I mean, I think there's a level of misunderstanding with how these different things work. And then almost jumping on the bandwagon. Like, people have heard of Bitcoin, they think it's cool. You go around town here, you can even find places that have Bitcoin ATMs. Why? Well, I guess we're supposed to have a Bitcoin ATM. I think there's one outside of Walmart in Brown Deer. So what, you're gonna go and get your Bitcoin and then walk into Walmart and spend it? No. But there's a Bitcoin ATM right outside. Yeah, it's kind of an interesting thing. Go ahead.
My friend, I was super into crypto back in 2016. Bought it, like Steam lets you use Bitcoin, and he bought it very popularly. I was like, how much money did you actually spend on that? Like, obviously it's $30 Bitcoin back then. We did the math, it was like paid like $1,300.
Yeah, for a $10 for a $30 game. And there's worse stories than that.
Oh
yeah. Yeah, the original pizza. I taught a class here, I think it was in 2009 or 10, and Bitcoin was worth like 2 cents or something like that at the time. And there's YouTube videos are up there. They're all standard definition YouTube videos back then. And so I had all the students sign up for a website called Coinbase, and they gave you $10 worth of Bitcoin. And I, at least as far as I'm aware, there's one student who still had, I think he sold it now, but had that original $10 worth of Bitcoin. And when Bitcoin hit, you know, in that $70,000, $80,000 range, he sold it. And I think it almost covered his college education from that one class. I feel like I should get a cut. You know, it should be like a thing there. Like, look, like you took this class. He didn't even do well in it. He didn't. He was one of these guys didn't do his homework or anything. It was just a, no, but yeah. But him and I have remained friends. You can be a crappy student and still be friends. It's two separate hats, right? But it is interesting that that's a thing. Is and it's all speculative, right? You know, could have just as easily you get $10 and it was free $10 of Bitcoin. So, you know, you get $10 in Bitcoin today, it might be worth $4 tomorrow, and you know, 3 years from now, it's not worth anything. And we saw this last year with the Dogecoin. You know, Elon Musk from Tesla just started talking about Dogecoin was created years and years ago as like a joke. It's based on this meme of this dog, and it was created as this joke coin. And Elon Musk started running his mouth about it. The thing, people made millions of dollars off Dogecoin for just no good reason. It's ridiculous. It's comical, but it's ridiculous. So just kind of wrapping up this thing. I would say the most popular, the most computer science centric crypto out there right now is Ethereum. It suffers from some of the problems with Bitcoin. It still has a pretty big energy footprint, but it's not as bad as Bitcoin. It uses a technology that basically anybody who's mining Ethereum is using a graphics card. You don't have these specialized pieces of equipment that let you do it, so that at least puts some sort of reasonable, I still might say unreasonable, cap on the electrical usage. But Ethereum is kind of the poster boy for these new things called NFTs, which are non-fungible tokens. And with 3 minutes left, without going into crazy detail, think of an NFT as like the title of your car. When you have a car, you have this piece of paper, and this is proof that you own that car. All right. Now that title is registered with like the DMV. So you're reliant, you're trusting the DMV to keep track of, this is your car, this is my car, not your car, right? Well, what if we put that on a blockchain? So an NFT would be a token, even though it lives on the Ethereum blockchain, it might be your car title token. So the Ethereum blockchain has a default token that is Ethereum, but other tokens can live on that blockchain. It doesn't have to all be Ethereum. Okay, you can invent, you can have I can have the mic token that's on there. All right. So that's the idea of this NFT, is you get to choose how rare an NFT is. So kind of the popular thing these days is like digital artists have been creating paintings, something like that. And then, you know, if they make one painting, well, really, it's a single piece of digital art, right? But so if they make one, and then they put it on the blockchain, somebody gives them, maybe they're paying them in Ethereum. So here's 3 Ethereum, which is worth 12 grand, by the way. Stupid. Here's 3 Ethereum. And then you get this token that is a piece of art. All right. That happens out of these things called smart contracts. Smart contracts are computer programs that live on the blockchain, but they're not controlled by a human being, and they can't be reversed. So it's effectively an if statement. If 3 Ethereum came here to sent as input to this contract, the contract will send the piece of artwork to the source sender of the Ethereum. Contract complete, no human involvement was made. That's what a smart contract is. Okay, so it's actually a escrow system, if you will, that lives on the blockchain that doesn't involve trusting human beings. These are interesting uses of blockchain technology. And then that artist gets to decide the rarity of their art. You know, if they want to create one piece of artwork and I don't know, let's say it's really good, maybe somebody pays $1 million worth of Ethereum for it. But if they decide I'm going to create 50,000 of my artwork tokens, well, now all of a sudden it's less unique. Maybe it's not going to be worth as much. But the point is that non-fungible tokens say this guy does differentiate himself. So maybe this token has a print number of 0. This one has a print number of 1. They are different pieces of artwork instead of they're almost like baseball cards or something like that. So I would say that's our current cool kid with blockchain technology, is leveraging the security that we've talked about in here to have tokens that prove ownership of something. And that's done in the context of these smart contracts, which are tiny computer programs that live on the blockchain and are not controlled by human beings. They can't be reversed. So kind of an interesting state of things. All right, questions, comments, concerns, bribes. And I won't have any of smart contracts or stuff are things I think you should go and look into, but any blockchain stuff on the exam, I'll end at that idea of linked list. Here's a block has hash information about the other blocks next to it to add security to it. All right. All right. I will see you when I see you. If I don't see you in person before break, have a safe break, and I will see several of you back maybe in the 450 class in the spring. All right. Have a good one.